In this section we will learn the terms and definitions related to sample vaporization and how to properly vaporize a liquid sample and avoid common mistakes in the vaporization. We will start with some terms and definition to better understand the vaporization process. These two definitions are important to understand because all the vaporization process depend on them. The first one is the hydrocarbon dew point. The hydrocarbon dew point is the temperature, at a given pressure, at which the hydrocarbon components will start to condense out of the gaseous phase. The hydrocarbon dew point is a function of the gas composition as well as the pressure, meaning that it is the temperature at which the gases start forming liquid droplets. For the same composition, the dew point temperature change with the pressure of the gas, so we can draw a curve between the dew point temperature and the pressure, as shown here, and we will call it the dew point curve. At any point below the dew point curve, the composition is in the gas phase, meaning that, if the composition is maintained at pressure and temperature that are below the dew point curve, we are sure that the sample is 100% gas. Next important definition is the bubble point. The bubble point is the temperature, at a given pressure, where the first bubble of vapor is formed when heating a liquid, meaning that it is the temperature at which the liquid sample start forming gas bubbles. For the same composition, the bubble point temperature change with sample pressure, so we can draw a curve between the bubble point temperature and pressure and call it the bubble point curve as shown here. At any point above the bubble point curve, the composition is in the liquid phase, meaning that, if the composition is maintained at pressure and temperature that are above the bubble point curve, we are sure that the sample is 100% liquid. The area between the dew point curve and the bubble point curve is called the mixed phase area, meaning that in this area the sample will be a mix of gas and liquid. The more the point is near the bubble point curve, the sample is mostly liquid with gas bubbles. The more the point is near the dew point curve, the sample is mostly gas with liquid droplets. Let us understand what sample vaporization is. If the analyzer in your analytical system requires gas, but your sample is liquid, the only option is to convert the liquid to gas. This process is called vaporization or flash vaporization. It is not easy to vaporize a sample, nor is it always possible, so make sure it's really necessary and possible before you try. You should always analyze a liquid in a liquid phase unless there are strong reasons for analyzing in a vapor phase. The objective of sample vaporization is to convert a sample of all liquid to all vapor instantly, without changing the composition. The important word in this definition is instantly, meaning that the sample instantly transformed from all liquid to all gas without passing in the mixed phase region of the previous curve. If this is done properly, sample composition is not changed in this phase transformation process. To better understand vaporization process, let us differentiate between vaporization and evaporation. Evaporation occurs gradually with an increase in temperature. On the other hand, the vaporization occurs instantly with a drop in pressure. So the main actor in the evaporation is the temperature, while the main actor in the vaporization is the pressure. Notice also that the evaporation is done gradually and the vaporization is done instantly. It's not possible to vaporize a sample by increasing temperature. Heat causes evaporation, and adding more heat simply makes evaporation happen faster. In a mixed sample, evaporation will allow some compounds to evaporate before others, resulting in fractionation. This means that the gas-produced form evaporation is not the same composition of the liquid sample. Vaporization, done properly, ensures that all of the compounds vaporize at the same time, preserving the sample's composition. What can go wrong in the vaporization process? Instead of flashing the whole sample into a vapor, you could unintentionally cause a combination of vaporization and evaporation. The result would be fractionation. Once a sample of mixed compounds fractionates, it is no longer suitable for analysis. With fractionation, a common scenario is for lighter molecules to evaporate first and travel on toward the analyzer, while the heavier molecules remain behind in the liquid phase. Even if at some later point in the process a fractionated sample appears to be all gas, the mixture will not be of the same molecular proportions as it was before fractionation. It will no longer accurately represent the sample taken from the process line.